Wade.
Hey, Carly.
Today, let's talk about linear regression.
Awesome.
So we are actually going to take correlation just a step further and talk about how we can use X variables to predict a target variable Y.
Ooh, this sounds like machine learning.
Yeah, it actually is one of the algorithms of machine learning, regression. And so regression is basically just a fancy word that means we're going to use some variables to predict another. And I'm going to stick with this height and weight example. So let's say that we have a data set that contains heights and weights, and that we make a nice scatter plot of all of the people in that data set. And so this scatter plot tends to have a positive correlation. We would say here that the correlation coefficient is greater than 0 in this case because our points are sloping up and to the right. As our height increases, our weight increases. There is a relationship between these two variables. And so what regression does is says, let's use height to make a prediction for people's weight based on this data that's given. So basically, to do that, we need to create what we call a line of best fit through these data points. And regression can take many forms. Specifically in this series, we're going to dive into linear regression. And if we have one X and one Y, that is just represented with a straight line. So luckily, we have Python that can make a perfect regression line through these points. I'm going to kind of estimate the line by basically making what I called a line of best fit. So this is the line that makes the errors basically between the points in the line, this distance between each point in the line, the smallest.
So as a linear regression, the linear part means we can only draw a straight line. We're not allowed to curve it at all.
Right.
And then it's the line of best fit, so we can't make a better line. There's no way to tweak it at all to make it a better line. So this is the best straight line that we can draw at all. There's no way of doing better.
That is exactly right. And then what we can do is use this line as a means to make predictions. So I can say that if someone has a given height X, that I can go up to this line and say, okay, well, here's where the point on the line where the height is equal to X. And then I can actually estimate what the value of Y is for their weight. So I can make a prediction for any X value within my data set, what their weight would be. And we can use math. I'm going to look at how do we use math and formulas to figure out what this exact number is for Y. And then Wade, you're going to show us how to do this in Python, right?
Yeah, we're going to be able to take data, create a regression line with that inside Python, and then use that regression line to predict any value given in X to predict a Y.
Yes, and then there's two more things I want to say about regression. And the first is that we want to make sure that our predictions stick within our data. We don't want to try and make a prediction for, let's say, an X2 value out here if I have no data points, because we don't know. We know our regression line works for our specific data, but maybe once you get past a certain point, maybe it ends up having a negative correlation or it makes a shape that's not a line. So predicting outside of your range is called extrapolation, and we definitely want to avoid that.
So Python's going to let you predict anything because it's going to take this line and it's going to imagine the line out to infinity. So it's up to you as a data scientist to figure out where is the part of this line that becomes extrapolation and to make sure to not do that. Because Python will say, oh, you want somebody who's 1,000 inches tall? Done.
Yes, you are smarter than Python. And then the very last thing, the second thing I want to say about regression is that we only had, in this case, one X and one Y. So this is actually called, if we have one X and one Y, we call this simple linear regression. It's simple, it's not complicated. We just have one input and one output. But there is something called multiple regression, and multiple regression has many X's and one Y. And multiple regression is something that the math behind it is actually very complicated, but the Python code is actually pretty simple. So we're going to look at maybe using different x's, multiple x's. If we were predicting weight, maybe we would use something like gender or another variable that could influence the weight. And we can actually make better predictions a lot of the times if we have more x variables. So we're going to dive into both of these. Simple linear regression, we're going to look at the math and the Python. Multiple regression, we're going to look at the Python. But this is a really cool supervised learning technique that you guys can nerd out with.